Hello everyone, welcome back to Multivariable Calculus, and today we are going to cover equation of plane, which is a subtopic of three-dimensional space in our multivariable calculus. Okay, so today we will discuss how to find the equation of plane, under what condition plane and line are parallel, perpendicular. Okay, so let's get started with first thing, equation of plane. For that, let's say we have a 3D space, x, y, z axis, right? These are our x, y, and z axis. Now in these x, y, and z axis, we have to consider a plane. Let's say this is a plane whose equation is to be calculated. Now, in order to calculate the equation of line, if you do remember, we needed one point and the vector which is parallel to that line, because all the vectors which are parallel to that line are lying in the same direction. That's why line direction was same. But in case of a plane, if you consider any plane, okay, and let's say this pen and this is my hand is plane. So if I put it here, yes, right, can you see? Plane and this line are lying in the same direction. Even here, even if I change it, okay, if I take any line or any vector lying in the plane itself or parallel to the plane, there are infinitely many cases. So it means we do not have unique direction for parallel condition, right? So we need another thing. What is that? Normal. Actually, all the vectors which are normal to this plane are always what? In the same direction, either upward, downward, that's fine. Basically, the thing is they are collinear. Parallel, yes, all the vectors which are normal to the plane, right? So gives you the unique direction, right? So it means we cannot consider the parallel vector, we have to take the normal vector for the plane. So let's consider n vector is normal vector to this plane, means it is perpendicular to the surface of the plane. After that, let's say we are given a point having its coordinates x naught, y naught, say x naught, y naught, and the vector from origin to this is, let's say, r naught vector. And let's consider another point P, general point, x naught, y naught, z naught, because it is in 3D. So P is another point x, y, z, and the vector, position vector we can say from the origin, is, let's say, r vector. Okay. Now we have to find the equation of plane using this information only. What can I say? See, if I join these P and P naught, I'll get a vector lying in the plane, right? This one. PP naught or P naught P is a vector lying in the plane. And this vector which is lying in the plane and the normal vector to our plane, what is the relation between these two? These are perpendicular to each other, right? So from here I can say, if this is the condition, I can say my r minus r naught, right, final minus initial position, so pp naught basically is perpendicular to the n vector, or I can say what is pp naught, which is r minus r naught perpendicular to n vector. It means r minus r naught having dot product with n vector, this must be equal to 0. Because if two vectors are perpendicular to each other, their dot product is 0. Hence, this is our equation of line. You can also write it like this, r dot n minus r naught dot n vector. Okay, or you can say r dot n equals r naught dot n. See, r naught is a given point, right? N is also a normal vector which is also given. So this quantity is going to be a number, scalar number. So let's call it d. So if I write it like r dot n is equals to d, that is also correct. Okay. Next is, in place of r vector, if I write x, y, and z. Okay. So if I have, let's say, x, y, and z, and for n vector, the direction ratios of this n vector are, let's say, a, b, c. So dot product of x, y, z with a, b, c is going to be a constant number, let's say d. Now take the dot product. How we takes the dot product? We have to just take the product of the corresponding numbers. So for example, here we have a x, y, z and a, b, c. So if I simplify it with dot product, I will get ax, then plus by, then plus cz. Scalar product, right? It gives you a scalar answer. So equals to d. This is another equation of the line plane. This is Cartesian form. Okay, and that one was this one was vector form. So the sum up is whenever you have to find the equation of the plane, you need two things: normal vector to the plane and one point lying in the plane. That's it. And use this r dot n equal to r naught dot n first method to find the vector form. And if the direction ratios are a, b, c, then also you can use this ax plus by plus cz equals to d. For example, if I give you as a question, let me change the color. So equation of the plane as 2x plus 3y minus 4z equals to 7, let's say. So the normal vector to this plane will have the direction ratios as 2, 3 and minus 4. So if the equation of the plane is given, we can always find the normal vector. Okay. For example, in case of line, if we do remember, if the equation of line is given, we can find the direction vector, right? A vector parallel to the line as well as any one point lying on that line. But for the given equation of plane, we cannot determine the point lying on that plane. But yes, we do have the direction ratios of normal vector. Yes. Next part. Equation of plane. For the equation of plane now, as I said, we have this form which is vector form r dot n equal to r naught dot n. Second is this second form which is also called scalar equation of the plane. Okay. Now let's solve a question on this. We have to determine the equation of the plane that contains these 3 points. So 3 points lying on the plane are known to us, right? So how can we find the equation of the plane passing through these 3 points? Let's use the concepts of vector algebra. So let's say we have these P, Q and R 3 points. Okay, so all I need is a normal vector because I have 3 points. I just need one point only, but I have 3 points. But using these 3 points, first I will calculate a normal vector. And in order to find a normal vector, first I will make either PQ, PR or RQ, any two vector. Just form any two vector, and if I have, let's say, RP and RQ, just an example. So now let's take the cross product of these two. So if I take the cross product of RP vector with RQ vector, I will get my normal vector. Not only this, you can choose any vector. Okay. So for example, PQ cross product with PR. This gives me my normal vector. So basically the thing is we need to form two vectors using these 3 points and take the cross product of that, and hence we will get our normal vector. Okay. Now, so let's form the PQ and PR vectors to get the normal vectors. So what is the PQ vector? For the PQ vector, position vector of Q minus position vector of P. So 3, 1, 4 and minus of 1, minus 1, minus 2 and 0. So subtract them. Simplify it. So we get 3 minus 1 gives 2, minus 1 and minus of minus 2 gives 3, 4 minus 0 gives 4. That is your PQ. Similarly, let's find PR also. So for PR we have what? We have R as 0, minus 1 and 2 and P as 1, minus 2, 0. So simplify it. 0 minus 1 gives minus 1. Minus 1 minus of minus 2 gives plus 1 and 2 minus 0 gives 2 only. So this is your PR vector. Now take the cross product, right? You know how to take the cross product? Just write these in determinant form 2, 3, 4, minus 1, 1, 2 and leave this row and column corresponding to I cap. Find the determinant of these 3, 4, 1, 2. Okay, what is that? 3 times 2 is 6 and 4 minus, 4 times 1 is 4. So 6 minus 4 is 2. So 6, 2 I cap. Similarly for negative I j cap and so on, right? So I will get here 2 I cap, basically it is 6 minus 4 for I cap, and minus of what? For j cap, leave the corresponding row and column, you will get leave this as well as this. Okay, so what do you get? 4 minus of minus 4 means 4 plus 4, right? That gives me 8 j cap. Now for k cap, corresponding to k cap, leave the row and column corresponding to this, and we have what? 2 minus of minus 3. So 2 plus 3 means 5. So we have plus 5 k cap. So in this way we got the normal vector. Okay. So once we have the normal vector, we can use any of these 2 points, 3 points, okay, to get the equation of the plane. So here I am going to use this vector form. So what I have, I'll write it like this: dot product of r dot n. So r as it is, dot n is what? This 2 minus 8, 5 equals dot product of any point. Choose, let's say P, 1 minus 2, 0, and its dot product with this 2 minus 8 and 5. So this is your vector form, something like this. Either you can write r dot uh, 2I cap minus 8j cap plus 5k cap also. There are various representations, okay? So don't worry about the representation. Now take the dot product, so corresponding I cap, j cap, and k cap. So we've simplified, we get 1 times 2, 2, plus 16, 17, plus 0, 17 again. So this is our answer. This is the vector form. In order to get the scalar form, right, what you can do is you, instead of r vector, you can say xi cap, yj cap, zk cap. So let me write that on also for you. So you will get 2x minus 8y plus 5z equals 17, or if you take it to the left side, you will get this. Okay. And that is my final answer. So in this way, you can determine the equation of plane. All you need is one point lying on the plane and normal vector. They will give you any condition by which you can find the normal vector. Now, determine if the plane given by minus x plus 2z equals to 10. This is the equation of a plane. And the line given by this are orthogonal or parallel or neither. We have to determine that. Orthogonal means perpendicular. Whether this given plane, which is having the equation minus x plus 2z equals to 10, is parallel to this line or perpendicular to it, or there is no relation at all. That we have to check. How can I do this? If you do remember, if the equation of plane is given, we can find the normal vector of the plane. So here what is the equation of the plane? We have equation of plane as this minus x plus 2z. So basically 0y also there. So let me write 0y plus 2z equals 10. So from here I can say the normal vector to the plane is what? Minus 1, take the coefficients only. Coefficient of x minus 1, coefficient of y is 0, coefficient of z 2. So this is the normal vector to the plane. Now if this is the normal vector to the plane, we can also find the, since we have the equation of line, so we can also find the direction vector of the line, means a vector parallel to that line. So for that we have to convert this symmetric form to any other form, or we can say we have the parametric form. We can write it as x equals to 5 for the line, and y equals to 2 minus t, and z is equals to 10 plus 40. Either you can write it in this parametric form, or also you can write it in that Cartesian form. Okay, so what we have here, let's find the values of t from this. So we have x minus 5 from this, so there is no t in this. So I can write it as x minus 5 equals 0t. Basically, this x component of that direction vector is 0. Okay, now from the second one, what is t? Y minus 2 over minus 1 is t. And from the last one, we have z minus 10 over 4 is equals to t. So the equation of the line can be written as x minus 5 over 0 equals y minus 2 over minus 1 equals z minus 10 over 4. So the direction vector, let's write it as b vector, for that line is nothing but this 0, minus 1, 4. Okay. Now we have normal vector to the plane. We have direction vector of the line. So let's find the relation between these two. If these two are orthogonal, means perpendicular, then you can use the dot product to check that. Just find the dot product. If the dot product is 0, means they are perpendicular, right? Let's try with it. So we have dot product of n dot b vector. What is that? Let's find it. We will get their I cap coefficients, product of them, minus 1 into 0. Then we have 0 times minus 1. Then we have 2 times 4. What is that? It is 8, which is not 0. If this is not 0, means vectors are not perpendicular. Now we have to check whether these are parallel or not. For parallel, what is the condition? Are these two collinear? Parallel. For that, these must be scalar multiple of each other. Are these two? No. In this case, you cannot write n vector as some scalar multiple of b vector. So we can say n vector is not any scalar multiple of b vector. Right? You cannot find any lambda for which these two becomes multiple of each other. It means it is not parallel as well. So it is not orthogonal, not parallel. It means there is some angle between these two. Okay, so this line and the plane have some angle between them. Right? So that was all about the equation of plane, and I will say also told you how to find the equation of plane, and if the equation of plane is given, what can you determine from that? Okay. So I'll talk about the quadratic surface in the next session, which is very important for the multivariable calculus. Okay. Thank you for watching this. See you in the next part, and if you want, you can connect with us using this WhatsApp number for one-to-one sessions or group sessions. Okay. So if you have any other doubt or any question, feel free to connect with me using this WhatsApp number, Telegram channel, or you can write it in the YouTube chat as well. Bye bye. Take care.